There, this is video 426 about solving the diagram. Right, so we're going to go on a little adventure together. I did not pre-solve this, so I'm hoping it goes well, and it may end up being 2 videos. I'm not really sure, but let's see how it goes. All right, and all you gotta do is solve the diagram. So solving a diagram is kind of like solving a triangle, but basically all those little letters in there, we're gonna figure them all out. So the first thing I want to do is I'm going to highlight that triangle. If I could find a nice little sticky note, I'd put it there, but I don't know where it is right now. So, and we're going to solve this one first, and then we're going to worry about our second triangle. And what's the first thing we should do? Oh goodness, look at how they've got the variables and everything mixed up. All right, I'm going to call this side little a. I'm going to call this side little d. I know it's an x there. And I'm going to call this side little b. And what gets me excited is, look at that. There is a delightful mix where we can use the sine law. So I'm going to start by writing, you see over here? Yellow triangle. All right, so b over sine b, matchy matchy, is we can do this one. And I'm going to stick with what we usually do. I'm going to say a over sine a. I know there's a little m in there, and I'm just going to ignore it for now. So let's see that we have everything. So b is 29 over sine of 35 is going to be little a, which is 45, over sine a. All right. So that being said, we can calculate the value for sine. All right, I want, where can I, okay, move my paper so we can all see. There we go. So 35 sine. So 29 over 0.5736 is equal to 45 sine a. Cross multiply. 45 times 0.5736 is 29 sine a. I got that 57, this number on my calculator, so I'm just going to multiply by 45. And I'm going to get 25.8109. 29 sine a. Divide by 29. Divide by 29. Divide by 29. So 0.8900 is equal to sine a. So angle A is equal to, second sine, 63 degrees. All right, you can see that. So I'm going to just track here. M is equal to 63 degrees. There's one variable. All right, now, if we know, wait a minute, what's wrong? Based on my diagram, that can't be 63 degrees. So this is one of those tricky times where, remember, sine law says we had an angle, we had a side and an angle. And that's one where you got to be careful. So the actual angle is 100 supplement minus 63. 117 degrees. And when I started the question, I said, remember, pay attention. Sorry, you can see ran from there. Pay attention. That one's going to be a tricky one because when you have side, side angle, the angle you're solving for as part of that sine law can either be the angle your calculator gives you or the supplement of that. So you just got to pay attention to your picture. All right. Now we can figure out angle H. Or, okay, so it's H in here. I guess that's what we should call it. Angle H. And we have, there's 180 degrees in my triangle. And there's 35 up there. And there's 117 there. So 180 minus 35 minus 117 is 28 degrees left. So I'm just going to add that to my list. And I'm going to write on my diagram. So now we can find this side. Now I labeled it little d. My labeling is getting weird here. The angle is actually H. It's not that I can't do the question, I'm just trying to figure out how to keep this all figured out and straight for you guys. All right, so I'm looking at this one, and it pairs with that one. So, and we still have B from the beginning, where we had that nice matchy-matchy pair. So B over sine B is equal to, I don't know what to use here, so I'm going to follow my diagram. I'm going to get rid of that. I'm going to call it X over sine H. Okay, this is probably the only time ever. No, it's weirding me out. Leave it as X. I don't know how to label that because I know these should match, but it's because we've got this crazy diagram. So B over sine B, so 29 over sine 35 is equal to X, which we don't know, over H, which is sine 28. So 29 where can I put this? There. You can see it. I go there, yep, I can go all the way up there. 0.5736 is equal to X, which we're looking for, over sine of 28. 0.4695. All right, we're going to cross multiply. 29 times 0.4695 is equal to 0.5. So I have the 4695 on my calculator, so I'm just going to multiply the 29. 6147 0.5 and divide. Five, 7, 3, 23.7, and I'm looking at the sheet, and it looks like, well, one that looks like it's made a mess, but it looks like everything is in whole numbers, so we'll just call it 24. I'll add that up over here into my list. So there was variable there. We have h, we have m, and we have x. So my yellow triangle, we are all done. Now, our white triangle. So we need to find, what do we need to find? Nope. We need to find a couple of angles and a side. But this is really nice. Look at that. I thought for a second we were going to have to use the cosine law, but it looks like this is more sine law. So we've got, okay. So what are we going to call that side? We're going to call it A, or we're going to call it C. Again, these are not being all matchy-matchy just because my diagram's messed up. We'll give that one letter N. Okay, but you guys can see what I'm doing here. So A over sine C. So little a is 45 over sine C is equal to little n, which is 40, over sine n. Okay, remember this is the one I'm looking for. So I have 1, 2, 3 numbers and a variable. It's a little late to start over now, but if I was to start over, I would just redraw these triangles and relabel them, and then not worry about the letters, so that I'm not getting this. This is causing me to twitch a lot, A over sine C. But you can see from the picture, it's still my matching set. 45 over sine, so 45 0.9063 is equal to 40 over sine n. We're going to cross multiply here. Times 40, 36.2523. It's 45 sine n. So divide both sides by 45. Sorry, I just can't see that now. So divide by 45. 0.856 sine n, and then we do a second and sine, and we get angle n is equal to 54 degrees. I'm going to round that off. All right, so I'm going to go back up here. I'm going to add n to my list. All right, what is left? Oh, we got angle K. Well, we've done enough in our triangles. There's 180 degrees altogether. And we already used a 65-degree angle. And we just calculated a 54-degree angle. So let's see what's left over. Minus 65, minus 54. Well, I don't know what I just did, but that wasn't it. Minus 65 minus 4. I kind of like some of those calculators where they have a display where it shows you, so you can see what you punch when you make a mistake. Because of my phone, I'm just guessing I'm screwing up. And I'm screwing up again because that can't be right either. 180 minus 65 minus 54. There we go. 61 degrees. So I'm going to add that up here. K is equal to 61 degrees. And now that I know that, I can use my sine law again to find y. So the set I knew from the beginning, which was a over sine c, is equal to y over sine k. Now, again, that's just making me twitch. But it's based on the diagram. It's going to work. So a is 45 over sine c, so 65, is equal to y over sine of k. Now k angle was 61. Zero 0.9063 is equal to y over 61 sine 0.8746. Let's cross multiply. So I've got this number in my calculator, so just multiply by 5. 39.3579. And then we're going to divide. We get 43.42, which we'll just call 43 equal to y. Okay, now let's look at our very, very messy diagram. K is 61 degrees. And let's see. So C is my biggest, if I'm looking at the white triangle, C is the biggest one. And it is across from 45, which is the biggest side. And angle N was 54 degrees. And it's across from 40, which is the smallest. So it looks like we're all good. And just for fun, I'm going to show you a really crazy check. Well, it's a little bit of check, mostly it's review. If we just ignore all the big mess we had there, and we look at this, this, and that, that is a shape that has 4 sides. So 4 sides. I'm going back to the end of chapter 2. 2 triangles. There should be 2 times 180 degrees. And if you don't believe me, it divides into 2 triangles. Well, look, there's a yellow one and a white one. Where I'm going with this So if we add up all the individual angles around there, we should get a 360 degrees. So let's start here. 117 plus the 35 plus the 54 plus 65 plus 61 plus 28. And I'm hoping when we add it up, 117 plus 35 plus 54 plus 65 plus 61 plus 28. Yes. So a little bit of a check to see that my angles are reasonable, because in a quadrilateral, right, four-sided figure, you can divide it just like our picture did into two triangles, which is 360 degrees, and we added up all the ones that we calculated all the way around. It worked out to 360 degrees too. Awesome. Have a great day.